Howdy, today on Flipping Sides we'll look at renewable and non-renewable energy.
Am I only dreaming, or is this burning an eternal flame? Say my name, sunshine through rain, my whole life so lonely, come and ease the pain.
So the science understandings we're going to look at, fossil fuels have been formed over geological timescales by anaerobic decomposition. They're considered to be non-renewable. Carbon-based fuels provide energy and are a feedstock as well for chemical industry. Discuss the advantages and disadvantages of using carbon-based fuels as a source of heat energy compared with their sources of feedstock. Their renewable energy is generated over timescales of years to decades from sources that are replenished much more quickly. So identify bioethanol, biodiesel, sunlight and wind as renewable energy sources and compare contributions of fossil fuels to global warming with those from renewable energy sources. So let's start by talking about fossil fuels. So fossil fuels are produced by the anaerobic breakdown of organic matter over a really long period of time. We're going to start by looking at coal. So coal is produced from normally plant organic matter that's been covered over, compressed and heated until it changes chemical structure. So down here we have a swamp around about 300 million years ago. Those plants died, they fall over, you get layers of sediment sitting on top. Over time that sediment builds up and you get a decent amount of pressure pushing on the dead plants. As the pressure builds up, the plants get pushed deeper underground. That increases the heat that's being put on them, and over time you get a chemical change of the structure of the organic compounds into coal, which is it's an arrangement of carbon really. So, like I said, most of the coal from today that we're using to burn to generate electricity comes from around about 300 million years ago, the Carboniferous period. Oil and gas follow a similar pathway. It's still anaerobic breakdown, but this time rather than being trees and plants, it's microorganisms in ocean or lakes, usually zooplankton or phytoplankton. So these are microscopic, very small. Again, they sink to the bottom of their waterway, normally oceans, but occasionally it can be lakes as well. Again, you get sediment building up on top. That seals them off from oxygen, so there's no oxygen available. As the sediment builds up, you get the organic matter getting pushed deeper down under the ground. Again, that warms up, it gets hotter the deeper you go down underground. So with the heat and pressure, you get a chemical change occurring and you get your oil and gas being produced. So crude oil is a mixture of hydrocarbons of various lengths, from around about 4 or 5 carbons up to 20, 30 in extreme situations. Whereas gas is a much shorter chain, so these are 1, 2, 3 normally. It's methane, ethane, propane. Now the key here, this takes millions of years, as does the formation of coal. So because these sources take a very long time to be produced, and the way that they replenish themselves takes a lot longer than a human lifespan, we call these non-renewable resources. So what that means is we're using the resources much more quickly than they can possibly be renewed. If it takes 300 million years to make the coal that we're burning now, the amount of organic matter, plant matter that's being turned into coal over the course of a year is minuscule compared to the amount that we're burning. So they're non-renewable because we can't remake them in a similar time frame than we live in. Now it's also important to recognize that fossil fuels are also feedstocks for many industries, particularly the petrochemical industry. So crude oil, gas, coal, they're used, and the compounds within the crude oil, gas and coal are manipulated to produce new compounds that we use all over the place. So adhesives that are holding this laminated wood together, carpets, cosmetics, fertilizers, plants, synthetic rubber that we use in tires, fabrics like nylon, plastics in general. Pretty much all plastics are produced from petrochemicals these days rather than renewable resources. So the petrochemical industry uses the compounds present in crude oil, gas and coal to produce new compounds with new features that we use. So that's why they're a feedstock, so they're a beginning for the production of new compounds. So you need to be able to compare the advantages and disadvantages of using carbon-based fuels to their use as a feedstock. So there's advantages and disadvantages for both. So let's go through the advantages first. Carbon-based fuels have a high energy density. There's a lot of bonds in a very small space, and they pack together really, really tightly. So what that means is if you burn a carbon-based fuel, you get a lot of energy being released per unit mass or per unit volume. So they have a high energy density, which means you get a lot of bang for your buck. Currently there are still large reserves of coal and oil and also large reserves of gas. And those large reserves of coal, oil and gas can be used both as a feedstock currently and also for energy consumption. So they contribute in two ways there. Natural gas has its advantages too. It burns clean as long as there's enough oxygen being supplied, and usually there is. Atmospheric oxygen is ample enough to completely burn natural gas. So it burns relatively clean, and it doesn't release as much carbon dioxide as other carbon-based fuels do. So natural gas is very handy, and because of this, and it's relatively easy to access, natural gas is being used increasingly more over things like coal. Now let's have a look at the disadvantages. The disadvantages, as we've said, they're non-renewable resources, and this is particularly important for the use of a feedstock. If we're burning all our oil, then we won't have any oil left over to make things like medicines, to make things like our clothes, to make things like plastics. So there's an issue there, since it's non-renewable, that once they're burnt, they're gone. There's lots of issues with burning these things, but if you burn coal in particular, normally coal contains levels of sulfur, and that sulfur gets released in the atmosphere, sulfur dioxide, and then we form sulfur trioxide, and then we have acid rain being produced. So that's an issue where you're burning coal for energy. The other issue that we're going to talk about shortly is carbon dioxide is being produced in this combustion process. And carbon dioxide, it's built up in the atmosphere, contributes to the enhanced greenhouse effect. And like I said before, how do we produce petrochemical products when we don't have any reserves of precursors like coal, oil and gas? What happens when they're gone? So let's contrast non-renewable energy sources with renewable energy sources. So renewable energy sources renew themselves on much shorter timescales. So rather than millions of years, it can be over the course of a few years or a decade or so. So let's talk about some of the sources of renewable energy. Solar panels generate electricity from light, and the way they do that is kind of complicated. The basics of it is there's a layer of silicon in the solar panel, or two layers really. When light hits the layer of silicon, electrons get displaced. Those electrons get carried through wires in a particular direction. That generates an electric current. So all you need for solar panels to work is enough light to hit them to generate that current. If we look at a wind turbine, wind hits the blades turn the hub turns the shaft, the shaft goes through gearboxes, so it gets stepped up, and then eventually you get a generator. This is the turbine, magnet spinning around wires normally, and that generates an electric current. So to generate wind, all you need is sun. Sun heats up air. When air gets heated up, it moves, and moving of air is what we call wind. So in both cases, as long as we have the sun shining, you get energy being produced. Biofuels are indirect products of photosynthesis. So bioethanol and biodiesel are the main biofuels we're going to talk about. So bioethanol can be produced from pretty much any organic plant matter, normally plant matter because that's full of carbohydrates, and you just have to ferment it to produce ethanol, which is alcohol. And then you can burn that alcohol in car engines and use that to drive your car along. Biodiesel is produced from oils and fats, so it can be plant-based or it can be from animals. You need to do a little bit more chemistry there in terms of the treatment, but the product you get out of it is the biodiesel that can be burnt in regular diesel engines. The key aspect of both of these, though, is that they're the product of photosynthesis. If we're talking about oils and fats, if it's oils, it's coming from plants, so plants are doing photosynthesis to generate the energy to make the oils to start with. If we're talking about animals that are producing fat that we're using to make our biodiesel, those fats are produced from animals that are eating grass, which is your photosynthetic product. Your grass is a plant. So they're really just taking carbon dioxide from the air and turning that into a fuel, and that's why they're better for the environment. We'll look at that right now. So because of our manufacturing processes, all our energy sources, they have some kind of global warming impact. But some processes, particularly the renewable ones, you can negate that global warming impact from the production. So if we look at solar panels, for example, they'll pay for themselves in terms of the energy and carbon cost in their manufacture in around about 4 and a bit years. So 4 to 5 years, depends on which study you look at, and depends on where you are as well in the world, because if you get lots of sunlight, you pay off quicker. What that means is it takes a lot of energy to melt the silicon to make the silicon ingots that make the solar panels. So that solar panel has to make back that energy in order for it to be a benefit to the environment. And they'll do that over 4 or 5 years. Wind turbines, they can easily make their manufacturing energy costs within a year or so. So down here I have a little bit of a table that's showing that. So the minerals and the land that goes into putting a turbine up, you never get that back. But over 20 years, the energy cost will be paid off here. This study is 146 days, so that's much less than it's about half a year. The carbon is regenerated in just 94 days from this study. So what that means is all the carbon that goes into the manufacturing and the production of the wind turbine is paid back by the wind turbine generating electricity and not burning carbon while it's doing that. Biofuels, they have a reasonably negligible impact. We'd call them reasonably carbon neutral because they're coming from carbon in the atmosphere. So the carbon dioxide from the atmosphere goes in. In this case, they're looking at using algae to produce the biofuel. So the algae are using solar energy, which is free, carbon dioxide, which is present in the atmosphere, to produce the fuel. And when the fuel is burnt, carbon dioxide is released. But there's no net gain in carbon dioxide from this process. And in reality, there is, due to the extraction and the production processes. They produce some carbon, but it's much, much smaller than the carbon cost of burning a litre of petrol, for example. So we need to talk about why fossil fuels are worse. So fossil fuels are worse because they're releasing carbon that was in the atmosphere millions of years ago. So it was in the atmosphere, it got locked up in a plant or a small organism that then over millions and millions of years gets turned into a fuel that we burn. We're putting that carbon out at much higher levels than the Earth can reabsorb it in things like plants or in the ocean safely without causing negative effects. So here is the Keeling curve that they've been measuring carbon dioxide on this volcano in Hawaii. And the carbon dioxide, it isn't being reabsorbed. The extra carbon dioxide that we're putting in isn't being reabsorbed because the levels of carbon are just increasing and increasing and increasing. If they were being reabsorbed, then we would see this graph go up and then come back down as the carbon dioxide is being reabsorbed, but it's just not doing that anymore. The extra carbon dioxide leads to the enhanced greenhouse effect, which is global warming. Now, I've got a video that I'll show you on global warming, so let's have a look at that now. So this video shows global atmospheric concentration from about 1958 and also the average temperature of the Earth for that period based on the average from, or the mean from 1951 to 1980. So let's play it. So over here we're seeing the carbon dioxide level is slowly increasing. The mean global temperature is increasing as well. Until we get to this point here where we're pretty much at the modern day and we see the global atmospheric carbon dioxide concentration is increasing, as has the mean temperature. So now we're about 1.3 degrees above that mean from 1951 to 1980. And there's no question that these are related to each other. We need to think about that when we're using fuel sources in terms of their impact on the environment and what's that going to do for our future. So today on Flipping Science we looked at renewable and non-renewable energy sources. That's it for Flipping Science today. See ya.